Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's video, we will shift our focus from chemical reaction engineering to heat transfer operations. Heat transfer operations, or we can call it as HTO, has a very significance in the field of chemical engineering. So now we will cover two lectures on the heat transfer operations. And today we will start from the basics of the heat transfer. That firstly, it will be an introduction of heat transfer, the thermodynamics and heat transfer operations linkage, the laws of thermodynamics, the driving force of heat transfer, and the applications of heat transfer in practical life. So before going to today's lecture, if you have not subscribed to the channel yet, please to subscribe to the channel. Click on the bell icon to get all updates related to this channel. So going to the introduction, that the science of thermodynamics deals with the amount of heat transfer as the system undergoes a process from one equilibrium state to another, and make no reference to how long the process will take place. So the thermodynamics will give us information about the energy, the amount, but it will not give us information relative to the time. In engineering systems or in engineering philosophy, we are often interested in the rate of heat transfer, that how much time will it take for the transfer of heat, and that aspect is covered in the science of heat transfer. Thermodynamics will give you an information of amount, but the heat transfer will give you the information about how much amount will be shifted per unit time. Let's assume that we have a cold canned drink, which is, if it is in a cold state, if you have left it in the room, it warms up. On the opposite hand, if you put a warm drink in refrigerator, it cools down. Why it happens? Because of the transfer of energy from warm medium to the cold medium. Obviously, the energy will be transferred from high temperature source to low temperature source. In thermodynamics, energy exists in various forms. It could be internal energy, it could be kinetic energy, it could be potential energy, it could be heat. But in heat transfer aspect, we are primarily interested in the heat, which is the form of energy that can be transferred from one system to another because of the temperature gradient or temperature difference, or we can say it as one system is hot and one system is comparatively cold. So the heat will be transferred from high, medium, or high temperature source to the lower temperature system. And the science which deals with the determination of rates of such energy transfer is called as the heat transfer. As you can see, this coffee, which is in this mug, it is at 70 degrees centigrade, while the environment temperature is 20 degrees centigrade. So considering the science, the heat will be transferred from coffee to the cool environment. The amount which will be determined from the thermodynamic analysis, while how much time will it take to reach to a certain temperature will be decided by the, or will be governed by the heat transfer. Let's assume we want to know how much heat is transferred once a coffee inside a mug goes down from a temperature of 90 to 80 degrees centigrade. So the amount will be dictated or will be calculated by the thermodynamic analysis. But the designer or the user is primarily interested in how much time will it take for this mug or this thermos bottle to cool the coffee from 90 to 80 degrees centigrade. Obviously, thermodynamic analysis alone cannot answer this question. So for answering this question, you have to inculcate the concept of the heat transfer. Determining the rates of heat transfer to or from the system and the times of heating or cooling as well as the variation of temperature is the subject of heat transfer. But we need to know what is the difference between thermodynamics and heat transfer. That thermodynamics deals with the equilibrium states and changes from one equilibrium state to another equilibrium state. However, heat transfer deals with a system that lacks thermal equilibrium, and so we can call it as non-equilibrium phenomena. We can say that the study of heat transfer alone based on thermodynamics cannot be carried out. That the heat transfer inculcate the laws of thermodynamics as well as the time calculations, the steady state and steady state calculations as well. However, it definitely follows the laws of thermodynamics. What are those laws of thermodynamics? That the first law requires that the rate of energy transfer into a system must be equal to the rate of increase of energy of that system. We all agree that if you add 20 joules in a system and its initial energy was 100, with the addition of that 20, it should be 120. That is the first law of thermodynamics for the energy. And the second law is that the heat to be transferred in the direction of decreasing temperature. As you can see in this system as well, that it is transferring from 70 to 30 degrees centigrade in the direction of decreasing temperature. So the laws of thermodynamics are part of heat transfer system. But as I have told you before, that thermodynamic analysis will give you the information about the amount of heat transfer or the amount of heat, but to calculate it with respect to the time, it will be governed by the heat transfer operations. Now, the driving force of heat transfer. Obviously, in our previous slides, we have seen that we are continuously saying that time, temperature, temperature. So the basically heat is transferred when there is a temperature difference in the system. So it means that if there is no heat transfer takes place, if there is no temperature difference in the system, so obviously the driving force for heat transfer will be the temperature gradient, the temperature difference, in the same way as that of the voltage difference for electric current flow or pressure difference for a fluid flow. However, the rate of heat transfer in a certain direction, as per the second law of thermodynamics, it depends on the magnitude or the amount. For example, if there is a delta T of 10 degrees centigrade, the heat transfer will accordingly take place. If there is a delta T of 100 degrees centigrade, or we can say the larger the temperature gradient, the higher the rate of heat transfer. Lower temperature difference, low amount of heat transfer. High temperature difference, high amount of heat transfer. So it is basically to be understood that the heat transfer driving force is temperature difference. Higher the temperature difference, higher the rate of heat transfer. Coming to the last slide, that the applications of heat transfer. So the best application is the human body, that we are daily emitting energy into the environment. Air conditioning system, heating system, refrigeration system, power plants, electronic equipment. So all of these exhibit the phenomena of heat transfer in the real life. If you look at the real life, you will get all the examples related to the heat transfer. Just coming to the conclusion that the thermodynamics will give us information about the amount of heat or the amount of heat which can be transferred from one medium to another medium, but how much time will it take place? It will be confirmed by the heat transfer operations, that it will give you information about the rate of heat transfer. Then coming to the second point, that the heat can be transferred when there is a temperature difference in the system. If there is no temperature difference, heat cannot be transferred. So heat transfer is basically based on the laws of thermodynamics as well. So I hope you have understood all the aspects of this lecture. If you have any queries, feedback, suggestion, please provide it in the comment box and I would be happy to answer it. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.